That's enough for the small talk. So now you guys got to pay attention, right? Over here. Alrighty, let's see. This is a frequency table, and you know it's a frequency table because of the fact that you see the frequency there. It's a list of frequency for various bins, right? But I think I gave it away. How is this data organized? How do we organize this data? Do you guys know? Gave it away. So if you were listening, you would know. You guys know what's the most important thing you could ever do? What's something that you learned growing up? Not always, but you got to learn how to what? Listen. Listen. Listening skills. If you could pass that on to children, you've done a lot. Okay? So let's see. How is this data organized here? What are these called? Bins, is that right? Good. These are bins. So this is the first bin, second bin, third bin, fourth bin, and the fifth bin, okay? First bin holds data values from 0 to 5. Do you guys know how many data values does exist in this bin that consists of maybe the value 2? Does anyone know? Can't tell. All you know is that there's 3 values in this what? In this bin. Is that true? Okay. All right. Good. Now let's see if you recall from last week. What does this table represent? What does it say here? It says, how far do you live from campus? So this example is really data that was collected, organized in bins, where some people responded that they live between 0 and 5 miles away. Right? Between 0 and 5, 3 people responded they lived between 0 and 5 miles away. 5 people responded that they live between 6 and 11. 10 people responded that they live between 12 and 11. 4 people responded that they live between 18 and 23. 2 responded that they live between 24 and 29 miles away. Okay? So let's see. What are we going to do with this? This is what this table is. How do you compute a relative frequency? Anybody know? How do you compute that? What do you do? Relative frequency, let's recall from last week, is a frequency divided by n. What is n? Sample size. Good. N is the sum of the what? Frequencies. So i.e. together, you can think of relative frequency as the frequency divided by that as well, okay? However you organize this information, it's up to you. But for every bin, there's an associated relative frequency. So how many data values are in this table? How many? 24? Okay. That's your, excuse me, that's your n, is that right? Okay. So now we have 3 over 24, which is approximately a value. 5 over 24, approximately a value. 10 over 24, approximately a value. 4 over 24, approximately some value. And 2 over 24. Okay? Now, one thing that's missing here is that they didn't tell you how to approximate your relative frequencies. Is that true? All right, so let's see. There is a way to do this, but I won't go over it at the moment. Or should I? No, we won't go over this at the moment. Let's approximate this to the nearest thousandths. Okay? What does that mean? How many decimals? 3. Good. What's 3 over 24 approximated to the nearest thousandths? 0.125? Good. Okay. 5 over 24? 0.208? Okay. 10 over 24? 0.417. 4 over 24? 0.167. And finally, 2 over 24? 0.083. So this here is now a relative frequency table. You've answered the question. If you converted these things to percents, what's the problem? You weren't supposed to because they didn't say to create a what? A percent table. Is that right? They said a relative frequency table. So here's your relative frequency table. Okay, you guys okay with that? Is that easy or is that hard? Okay, well, we're going to think about what comes next. We're going to now talk about pictures of data. Pictures of data. So far, what have we done so far? We've gathered data. We've organized data. And so now we're going to look at pictures of data because what you're going to see is some of these distributions have sort of an interesting shape. So we're going to start to talk about that. But in order to talk about pictures of data, what I'm going to have to do is give you a bunch of definitions, okay? And I'm going to try to use the language that's sort of consistent with the language I've been using, because you can call these things bins, you could call them classes, you can call them groups, you can call them intervals, you can call them all those things. But I've been trying to keep the language consistent and just refer to them as bins. Okay, so you're going to look in your book and they may have a slightly different definition because they might have replaced some of the language with class or group or interval. Okay, but I'm going to define for you here. This is now definitions in regards to bins. I'm going to define for you two things: the lower bin limit and the upper bin limit. Okay, lower bin limit and the upper bin limit. Okay, the lower bin limit is the smallest data value that a bin holds. Okay? What do you think the upper bin limit's going to be? Good. It's the largest data value. Okay? Lower bin limit, upper bin limit. Now take a look at this. Let's try to borrow some red over here, see if this works. Somebody might have left a red marker. I'm going to abbreviate lower bin limit by maybe LBL for lower bin limit. And I'm going to abbreviate upper bin limit UBL. Okay? So if I go to now my table again, and I'll have to write it down again. Distance, and this is measured in miles. Frequency, 0 to 5, 6 to what? 11, 12 to 17, 18 to 23, 24 to 29. And then the frequency values are going to be 3, 5, 10, 4, and 2. Okay? So what I'm going to do now is locate the lower bin limit and the what? Upper bin limit for each bin. So who can tell me? What do you think? The first bin here, right? What's the smallest data value that first bin holds? 0. Oh, it's too easy. What's the largest? What's the largest? 5. Oh my God. You guys okay with that definition? Right? What's the second bin? What's the smallest data value the bin holds? 6. The largest? 11. Next, 12. What else? 17.